welcome back. We'll continue talking about derivatives of logarithmic functions. Let's pick up with another example. So let's take the derivative of the natural log of the cube root of x to the fifth minus 6x plus 1 all to the fourth times 4x minus 13 all over 5 minus 7x minus 11x squared. Now, if we were to solve this by doing the derivative of the inside function over the inside function, then you see that we would have, this would be all to the 1/3 power, so we would have power chain rule. Inside a power chain rule, we would have our quotient rule. Inside our quotient rule, we would have our product rule. And inside that product rule, we would have another power chain rule. Solving it that long way would be pretty miserable. But that's why we have those properties of logarithms that would help us in this situation. So what we want to do is expand our logarithm into as many logarithms as we can first, and then take the derivative. So we'll rewrite that cube root as all being raised to the 1/3 power. What you're taking the logarithm of is being raised to a power. We can bring that power out front, and it becomes a coefficient. We're taking the natural log of two things being divided. We can take the natural log of the numerator minus the natural log of the denominator, keeping in mind that 1/3 gets distributed to both. Here, I'm taking the logarithm of two things being multiplied. I can turn that into two logarithms being added. Again, the 1/3 goes to both. And here, what I'm taking the logarithm of is all being raised to a power. I can bring that power out front. And this one big logarithm expands into these three smaller logarithms all being added and subtracted. Now that I've expanded my logarithm, now we can take the derivative. This 4/3 is a coefficient, and then we'll do I prime over I, plus 1/3 times I prime over I, minus 1/3 times I prime over I. And so we have the inside function on the bottom, its derivative up top. This inside function on the bottom, its derivative up top, minus 1/3 times this inside function on the bottom, its derivative up top. And you're welcome to distribute the 4 and the 3, the 1 and the 3, and the -1 and the +3, if you so choose to do so. Now let's take a look at this. Why is this one different than all the ones we did in the previous video and the one we just did? This is not a natural log. This is log base 3. But if you recall from previous knowledge, we do have a change of base formula where we can take log base 3 of x and turn it into a natural log. And we get the natural log of what you were taking the logarithm of, in this case x, divided by the natural log of the original base, in this case 3. Now, this natural log of 3, there's no variable there. That is an actual number. E to what power equals 3, there is a value to that. So this right here is just a constant. So you can pull it out. Just like we did if it was just a 3, then we'd multiply by 1/3. It's a natural log of 3, so we'll multiply by the natural log of 3, 1 over the natural log of 3. So now this is just a coefficient. So when I go to take the derivative, it'll just carry through and multiply in times the derivative of the natural log of x is 1 over x. And if you want to combine those together, multiply the 1s, multiply the natural log of 3 times the x, you can. We typically put the x out in front to make sure you don't think that that's the natural log of 3x, that it's x times the natural log of 3. Let's look at another one. Here we have log base 7. And again, the only derivative rule that we have is for the natural log. So we'll take this log base 7 of 3x minus 8 and we'll turn it into a natural log. Remember that formula, it's the natural log of what you're taking the logarithm of. Well, we are taking the log base 7 of 3x minus 8, so it'll be the natural log of 3x minus 8 divided by the natural log of the original base. Now again, right here, there's no variable. The natural log of 7 is a number. You can plug that into your calculator. So this is just a coefficient. We can pull it out and multiply it in. And then for the derivative of the natural log of 3x minus 8, it'll just be I prime over I, the derivative of the inside function over that inside function. Here we have another one. This is the common log, and if you recall, this is going to be base 10. So it's going to be the natural log of what you were taking the logarithm of divided by the natural log of 10. So now, this is really 1 over the natural log of 10 times the natural log of this. The derivative will be the derivative of this over this, right? The derivative of the inside function over the inside function, with that 1 over the natural log of 10 being a coefficient out front. All right, so let's play around a little bit more. Let's find the equation of the tangent line to the curve f of x equals the natural log of x plus 3x squared at x equals 1. In order to write the equation of any line, you need a slope and a point. Let's find our point first. Our point The y value will be the function evaluated at this given x value 1. So that'll be the natural log of 1 plus 3 times 1 squared. The natural log of 1 is 0. 3 times 1 squared is 3. And 0 plus 3 gives us 3. So the point we are at is 1, 3. Now we need a slope. The slope of a tangent line is found by the derivative. So we'll take the derivative of this function. The derivative of the natural log of x is 1 over x, plus the derivative of 3x squared is 6x. Now remember, the derivative gives you the formula to find the slope of the tangent line at any point. We don't want it at any point. We want it specifically when x is equal to 1. So the slope we're looking for is the derivative evaluated at 1, which is 1 over 1 plus 6 times 1, or 7. So now that we have a slope, 7, and a point, 1, 3, we can now find our equation y equals mx plus b. We'll plug 3 in for y, 7 in for m, 1 in for x, and we'll solve for b. And we get b as -4. So we can put it all together, and the equation of our tangent line is y equals 7x minus 4. Let's find d2y over dx2 for the natural log of x squared minus 3x. Remember what this means. This is the derivative of y twice with respect to x both times. This is asking us to differentiate y 2 times or find the second derivative, both with respect to the variable x. In order to find the second derivative, we're going to need the first derivative. The derivative of the natural log of an inside function is the derivative of the inside function over the inside function. And now when we go to take the second derivative, we're going to have to use our quotient rule. The derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So the derivative of the top is 2 times the bottom is x squared minus 3x minus the top is 2x minus 3 times the derivative of the bottom is 2x minus 3 all over the bottom squared. Here I'll distribute this 2. Here I will distribute this out. Everybody in the first group will get multiplied to everybody in the second group. But notice I'm going to subtract that product, so I'm going to keep that in parentheses. 2 times 2x is 4x squared. 2 times -3 gives me that -6x. -3 times 2x gives me that -6x. And -3 times -3 gives me that positive 9. Notice I kept this negative out here. So now I will go ahead and distribute that negative into everybody there. And combine all of my like terms, and I get the second derivative as -2x squared plus 6x minus 9 all over that x squared minus 3x quantity squared. All right, let's look at one more type of example. The cost for producing x units of a certain commodity can be modeled by C of x equals 100 plus 25x minus 120 natural log of 6x. Find the marginal cost to produce 100 units. Remember what marginal cost is. The marginal cost is how quickly the cost is changing at any given moment. How quickly something is changing at any given moment is the instantaneous rate of change, so the marginal cost will be the derivative of the cost function, which will be 0 plus 25 minus 120 times I prime over I, and notice the 6's will in fact cancel. So we found the marginal cost. Now to produce 100 units, we will plug 100 into that derivative to get 23.8. Word problems are asked in words, so they should be answered in words. So what does this mean? The cost will increase by $23.80 when the 101st unit is produced. In other words, it's going to cost $23.80 to make that 101st unit. That's it for now, and I will see you next time.